Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 11, and today we're looking at Section 11.2, which is solving quadratic equations by the quadratic formula. You may notice that this PowerPoint looks a little bit different than what you're used to. So it must have been that at some point I got a little lazy or pressed for time and borrowed the publisher's PowerPoint. However, the examples that are in here are the examples that I had always used up to that point. They're very carefully chosen so that they kind of accomplish two things at once. All right, so in addition to completing the square, which we talked about in the last section, another technique for solving quadratic equations is to use the quadratic formula. All right, so I have always felt that every student who uses the quadratic formula should spend at least a few minutes seeing where it came from. I don't want you to think that this was just made up by some sadistic math instructor just to torture you. Believe me, if we could make this formula any simpler, we would. All right. So what I'm going to do right now is I'm going to play this 2.5-minute video, which walks you through where the quadratic formula comes from. I am going to kind of talk you through it. You are not at any point going to be responsible for repeating any of this back to me. All right, so I'm going to talk you through this as it goes. All right, here we go. All right, thank you to Pick Rustable for this video. So the quadratic formula comes from completing the square on a general quadratic equation, ax squared plus bx plus c. So first we're going to subtract c from both sides. And then we are going to divide both sides by a. That's how we always get completing the square started. All right, and then next, we are going to do our magic trick. All right, so let me just pause the video really quick because they do this a little bit differently than how we talked about it in the last section. So what they're doing is they're taking b over a, which is the coefficient on the x term. They are dividing it by 2, which gives you b over 2a, and then they're squaring the answer. That's why we're adding b over 2a squared to both sides. All right, continuing with the video. Now we're going to simplify both sides of the equal sign. So applying that square to the two fractions and then finding a common denominator so that we can combine the right-hand side. You can see maybe why I didn't want to spend a whole lot of time on this. All right, so that gives us the right-hand side is b squared minus 4ac all over 4a squared. Now we're going to write the left-hand side as the square of a binomial. Then we are going to apply the square root property. I'm not crazy about the way they wrote this step. All right, but there's the plus or minus, so I like it better now. And finally, we are going to subtract b over 2a from both sides. And that's going to give us x equals negative b over 2a plus or minus that whole thing. And because those two fractions have a common denominator, we can combine it into one fraction. And we get this thing that you may have seen at some point before. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so there you have it, a quadratic equation written in the form ax squared plus bx plus c equals 0 has the solutions x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, over the years, math teachers and others have come up with, I should say, have tried to come up with all sorts of different clever ways to memorize this formula. One of them is to sing it to the tune of Jingle Bells. So x equals minus b plus or minus radical b squared minus 4ac all over 2a. Hey, which is okay. But a few years ago, a student told me about this, and I like this a lot better. I don't know if it's any easier to remember, but I think it's funny. So that's why I like it. So it goes like this. The negative boy could not decide whether to go to the radical party. Because he was too square, he missed out on 4 awesome chicks, and the party was all over at 2 a.m. Now, I don't know if you've ever had this experience where you search for something on the internet just to see if it already exists. So after my student told me about this, I thought, wouldn't it be great if somebody made this story into a comic strip? And somebody had already done it, right? Which I was very happy about because I don't have the talent to do this kind of thing. So just in case it's not clear, let me show you how the story fits in with the quadratic formula. Let me bring up my spotlight here. Okay, so it goes, the negative boy could not decide, that's the plus or minus, whether to attend the radical party. Because he was too square, he missed out on 4 awesome chicks, and the party was all over at 2 a.m. Isn't that cute? All right, I wish I could say I had made that up. All right, so now let's practice using the quadratic formula. So I'm going to switch over to my tablet, just checking to make sure it is ready. All right, here we go. All right, so the instructions for these first 3 problems are to solve the equation using the quadratic formula. So the first step for using the quadratic formula is to write the equation in standard form. So that means everything on one side, 0 on the other side. So I'm going to start this one by subtracting 14x on both sides. Now be very, very careful with the signs. If you mess up even one sign, unfortunately, the answers are going to come out wrong. So in this case, we get 5x squared minus 14x minus 3 equals 0. Once my equation is in standard form, I like to write down what a, b, and c are. Okay, so those are the coefficients of x squared, x, and the constant term. Notice I'm putting the negative with the 14 and the 3. All right, so now I'm going to write down my quadratic formula using whatever method you want to remember it. So in your case, you're using, you're allowed to use notes when you're taking your quizzes and exams. So in this class, it's not too important that you memorize it. In your next class, your instructor might expect you to have it memorized. So I would suggest trying to memorize it, but you don't have to do it this semester. All right, so we have x equals minus b plus or minus radical b squared minus 4ac all over 2a. Hey, all right. The next thing that I recommend is writing the formula without the a, b, and c and just put blank parentheses there. So minus blank plus or minus the square root of blank squared minus 4 blank blank all over blank. Okay, so spot we fill in a b. B was negative 14. In the second spot, we fill in a b, negative 14. Notice why it's important to have the parentheses there for that one. A is 5. C is negative 3. And A is 5. Okay. All right, so I think what I'm going to do now is go up top and just continue up here. because I really don't feel like copying all that on the next slide. Okay, so negative 14 is 14 plus or minus the square root of the square of negative 14 is positive 196. And then we have minus 4 times 5 times negative 3. So that's the same thing as plus 4 times 5 times 3, which is 60, all over 10, right? All right, and now 196 plus 60 is 256. And it just so happens that the square root of 256 is exactly 16. All right. So for this particular equation, we have two rational solutions. Rational meaning that you can write the answers without having to use a radical symbol. Okay, so my two solutions are, one of them has the plus, so that's 14 plus 16 over 10, which is 30 over 10, which is 3. And the other solution is 14 minus 16 over 10. 14 minus 16 is negative 2. Negative 2 over 10 simplifies to negative 1/5. So this equation has two solutions. Those two solutions are 3 and negative 1/5. And by the way, whenever you use the quadratic formula and get two rational solutions, it means that you could have solved the equation using factoring. All right, now they did specify they wanted me to use the quadratic formula, so this was the correct way to do it. It just means that you could also check your answer using factoring. All right, the 3 would have come from the factor x minus 3. This is not part of the answer. The negative 1/5 would have come from the factor 5x plus 1. You can multiply all that together and get the original equation back. Okay, but these are my two solutions. All right. There is one other thing that I want to point out because it's going to be helpful for later. Notice this number that was under the radical. In this case, it was a 256. The thing that I want to note about that number right now is that it is positive. And the thing that I want to note about the answer, the solution to the equation, the solution set of the equation, is that it has two real solutions. Okay, so just put that on the back burner. We're going to come back and refer to that later. All right, next example. X squared plus 2x plus 2. All right, so this one maybe is a little simpler to start off with. It's already in simplest form. A is 1, B is 2, C is 2. All right, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now I'm going to write it with the blanks. Negative blank plus or minus square root of blank squared minus 4 blank blank all over 2 blank. All right, so b is 2. B is still 2. A is 1. C is 2. A is 1. Right? Okay, so we have negative 2 plus or minus the square root of 4 minus 8, and that's all over 2. 4 minus 8 is negative 4, so this is negative 2 plus or minus the square root of negative 4 all over 2. This one I will continue on the next slide. Okay, and as we learned a couple of sections ago, the square root of negative 4 is 2i All right, so if you break that into two fractions, what you get is -1 plus or minus I. All right, so the two solutions of this equation are -1 plus I and -1 minus I. All right, so again, I can do it all on this screen. So the number under the square root is a -4, which is negative, and the solution set of this equation contains two non-real solutions. Keep that on the back burner for later. All right, one more quadratic formula example. We have this thing, 2/3 x minus 2/3 x squared minus 20/3 x equals -100/6. So what I always recommend when it comes to equations that have fractions in them is, before you do anything else, let's get rid of the fractions by multiplying both sides by the LCD. What would the LCD be for this equation? It would be 6, right? So let's multiply this thing through by 6. All right, 6 times 2/3 is 4. 6 times 20/3 is 40. And then 6 times -100/6 is -100. All right. So now we'll put this thing in standard form. We have to add 100 to both sides. That gives us 4x squared, whoops, minus 40x plus 100 equals 0. So A is 4, B is -40, C is 100. All right, so one more time, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Fun story, I had the same teacher for math 2 years in a row in high school. And during the summer between year 1 and year 2, I forgot the quadratic formula. And when we had our first test in the second class, I botched the quadratic formula because I'd forgotten it. That teacher made me write the quadratic formula 25 times, and I never forgot it again. All right. And I didn't hold him again. I did not hold it against that teacher. Still one of my favorite teachers from high school. He and I are Facebook friends. All right. So I know he was doing it for my own good. All right. So x equals negative blank plus or minus the square root of blank squared minus 4 blank blank all over 2 blank. Okay, so let me just peek, make sure I don't mess this up. So 4, -40, and 100. B is -40. B is still -40. A is 4. C is 100. A is 4. All right, so we have 40 plus or minus the square root of the square of -40 is 1600. And it just so happens that 4 times 4 times 100 is 1600. And that's all over 8. So look what happens under that radical. 1600 minus 1600 is 0. So we can ignore that term. It just falls off and it takes the plus or minus with it. So this is 40 over 8, which is 5. So this quadratic equation has one solution, which is 5. And one last time, notice that the number under the radical is 0, which is neither positive nor negative. And the solution set contains one real solution. So I think that's going to give us a nice segue into what we're going to talk about next. So let's get over there. All right, so that expression under the radical sign, they didn't exactly write this correctly. I'm just noticing that. I've probably looked at this thing 8 times over the last few years. It should say something like the expression under the radical sign in the formula, which is b squared minus 4ac. All right, b squared minus 4ac is not the whole formula. Anyway, that expression, b squared minus 4ac, is called the discriminant. All right, so what you've seen with these last 3 examples, because I very carefully chose them, is one example of each type of these. In the first example, the discriminant was 256. And in that example, we had 2 real solutions. In the second example, the discriminant was -4, and we had 2 complex but not real solutions. I like to just call them non-real solutions. And in the last example, the discriminant was 0. We had 1 real solution. So there will be times when you don't care exactly what the solutions are. You just want to know how many are there and what type are they. And if it's just asking you how many and what type, then all you have to look at is the discriminant. You don't have to do the whole quadratic formula. So let's do one example of that. Use the discriminant to determine the number and type of solutions for this equation. So going back to the tablet. All right, here's that equation. Notice that it's not exactly written in standard form. So just to be extra careful, I think I'll write it like this: 12x squared minus 4x plus 5. Okay, and because it was just asking for the number and type of solutions, all we have to look at is b squared minus 4ac. Okay, so in this equation, b is -4, a is 12, and c is 5. The square of -4 is 16. And 4 times 12 times 5, I think that comes out to 240. 16 minus 240 is -224. And the only important thing about that is that it is negative. So how many and what type of solutions do you have when your discriminant is negative? You have 2. You know what? I think I'll write this the same way your book does. 2 complex but not real solutions. All right, I like my way better. It's shorter. 2 non-real solutions. It does the exact same thing. All right, so now I just have one little application problem to show you, and I always remember this one. The first time I taught Math C out of this book, my A students were coming up to me. I remember it was a summer class. I can picture the room and everything. And my students were telling me, Mitchell, I think I understand what to do in this problem, but the computer keeps marking me wrong. So I thought, oh boy, well, there must be a really good reason for that. So the problem says, at a local university, students often leave the sidewalk and cut across the lawn to save walking distance. Given the diagram below of a favorite place to cut across the lawn, approximate to the nearest foot how many feet of walking the student saves by cutting across the lawn instead of walking on the sidewalk. So you see this diagram here, very helpful diagram. I don't even feel the need to do Mitchell's commandments for this problem, or at least not Mitchell's first commandment, because that picture pretty clearly defines what X is. So let's go back to the tablet one last time. Have set up that diagram. All right, and here we go. So this triangle is a right triangle. So you remember what we can do with right triangles? We can use the Pythagorean theorem, right? Okay, so playing the role of A in this problem is X. Playing the role of B is X plus 20. Playing the role of C is 50. So my equation is going to turn into X squared plus the square of X plus 20 equals 50 squared. All right, and we're going to solve that equation for X. All right, so X squared. Now I got to multiply out the square of X plus 20. So remember, you can FOIL that. My preference is that you use the special pattern for squaring a binomial, but I have found that not everybody likes to do it that way. So if you want to FOIL it, it's fine. X squared plus 40x plus 400. And then 50 squared is 2500. All right, combining like terms, x squared plus x squared. And while we're at it, why don't we subtract 2500 from both sides? So that's going to give me an equation in standard form, which says 2x squared plus 40x minus 2100 equals 0. All right. So A is 2, B is 40, C is negative 2100. All right, so X equals, or no, let's do it this way. The negative boy was unsure whether to attend the radical party because he was too square. He missed out on 4 awesome chicks, and the party was all over at 2 a.m. All right. Putting the blanks instead of A, B, and C. We get, let's see, B, I want to look. I'm afraid I'll mess it up. 240 and negative 2100. So 40, 42, negative 2100, and 2. All right, so negative 40 plus or minus the square root of 1600 plus, let's see, what is that? 16,800 all over 4. And 1600 plus 16,800 is 18,400. Okay. Now, normally, if they had just handed me this equation and said solve it, I would be looking for exact solutions, and I would simplify that radical and write the solutions in radical form. However, this problem said to round the answer to the nearest foot. So that means I am just going to ask my calculator, which my cat is sitting on, what is the approximate square root of 18,400? And my calculator says that the square root of 18,400 is about 1/35 0.65. You might be thinking, but Mitchell, why don't you just round that to 136? It said round the answer to the nearest foot. Well, I'm a little paranoid about rounding until we get to the very end of the problem. So I am going to put 135.65. All right. Now, of course, there are two solutions in there. One solution is with the plus, and that would be, let's see, negative 40. Let's do 135.65 minus 40 divided by 4, and that's about 23.91. The other solution is with the minus. So that's negative 40 minus 135.65. And that one comes out to about negative 87.8. Let me double check that. That sounds fishy. 135.65 divided by, oops, okay. Glad I did that over. Negative 43.91. Okay. Now remember what X stood for. X stood for the distance along the shorter distance along the sidewalk. So it doesn't make any sense for that distance to be negative 43.91. So that solution we can disregard. So is the answer 23.91? No, it is not, because remember what the question was. The question was, how many feet of walking distance? This is where my A students got tripped up. They figured out 23.91, but they missed the fact that that wasn't the answer to the question. How many feet of walking distance are saved by cutting across? Okay, so I think what I'm going to do is I'm going to draw that picture again. And this time I'll put in the actual numbers. So 23.9 was X, which would mean X plus 20 is 43.9. And the distance cutting across is 50. So the amount of walking distance that's saved is, instead of going 23.9, instead of going 23.9 plus 43.9, you just go 50. So the difference between going all the way around or cutting across. And that comes out to, I can probably do that in my head, but better safe than sorry. 23.9 plus 43.9 minus 50 comes out to 17.8. And this is where I can round the answer to the nearest foot. So you save about 18 feet of walking distance. All right, and that's going to do it for section 11.2. We'll see you next time.